Okay, so the first thing we're going to do, we're looking at number 3 now, and the first thing we're going to do is we will read the problem, circle any units of measurement, and then sort of come up with a loose plan if there's any conversions that need to be done. It is recommended that athletes drink a minimum of 0.24 liters of water for every 20 minutes of athletic activity. John plays tennis for 3 hours. His water bottle holds 1,500 milliliters. Will he have enough water to meet the minimum requirement? If so, how much water will he have left? If not, what's the least amount of water he will need to put in his water bottle when it's empty? Express your answers in liters. Okay, so a couple things I noticed. I've got liters and milliliters here. So the first thing I noticed that I need to do is I need to convert my liters, or my milliliters, into liters. And I know that because it says express your answer in liters. So I have a milliliter here, that's got to be converted. I also notice I have hours here that I circled, so I'm going to scan the problem and see if I notice any other units of measurement and time. And here I notice minutes. So I want to make sure that I convert so that they're in the same unit. So I'm going to say I'm going to convert my hours to minutes. So that's the first thing I want to do, is make sure that they're all in the same unit. So let's look here. I'm going to look at the milliliters, and I want to make sure that that's converted. So I have 1,500 milliliters, and that's equal to how many liters? I'm going to set up my conversion, milliliters to liters. I know that liters is bigger, and there's 1,000 milliliters in 1 liter. And in order to convert, I have to divide. So I have 1,500 divided by 1,000. I know I can just move that decimal 3 places. 1, 2, 3. And I have 1.5 liters. So I can take this measurement here, cross it off, and turn it to 1.5 liters. Now I have the whole problem of hours and minutes. So I think I'll probably convert everything to minutes. So 3 hours, I'm going to cross this off. 3 hours is equal to blank number of minutes. Well, I know in 1 hour, there's 60 minutes. So in 3 hours, I have to multiply by 60. 60 times 3 is 180 minutes. So instead of thinking of this as 3 hours, I'm going to think of it as 180 minutes. Once I've done my conversions, I'm going to read the problem again and think about if I need to draw a picture. So it is recommended that athletes drink a minimum of 0.24 liters of water for every 20 minutes of athletic activity. John plays tennis for 180 minutes. His water bottle holds 1.5 liters. Will he have enough water to meet the minimum requirement? If so, how much will he have left? And if not, what's the least amount of water he will need to put in his bottle when it's empty? Express your answer in liters. So I'm going to start to draw a picture of John's tennis. So John's tennis. And I know he's playing tennis for 3 hours. So 3 hours. But I know that every 20 minutes he has to fill his water bottle. So I'm going to divide this into 20-minute sections. So we said this was 3 hours was equal to 180 minutes. So I have 180. I'm going to divide that into 20-minute sections, because each one of those sections he's going to have to drink water. 20 does not go into 1. 20 does not go into 18. 20 will go into 180, and it will go in there 9 times. And I'm thinking of 9 times 2 being 18. So 9 times 0 is 0. 9 times 2 is 18. Okay, so I know John's tennis is going to be split up into 9 sections. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to count them to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one of these are 20 minutes. Okay, and I know every 20 minutes he has to drink 0.24 liters of water. So we want to figure out how much water he needs for the whole workout. Well, I can see that I have 0.24, and I'm going to multiply that by the 9 20-minute sections that are in his workout. So 9 times 4 is 36, 9 times 2 is 18, plus 3, 21. I have 2 decimals in my question, should have 2 in my answer. So I know that John will need 2.16 liters. If his water bottle is 1.5 liters, does he have enough? Well, the answer is clearly going to be no. So let's answer that first. Will he have enough water to meet the minimum requirement? No. He does not have enough water. He does not have enough water because he needs 2.16 liters. Okay, and he only has a bottle that holds 1.5 liters. If so, how much water will he have left? We've already established that he won't have any water left, so let's get rid of that. If not, what is the least amount of water he will need to put in his bottle when it's empty? Well, his bottle will empty after 1.5 liters. So we have, he needs 202.16 liters is how much he needs. So after he empties the first bottle, let's figure out how much is left for him to drink. So 6 minus 0 is 6. To borrow in from here, 11 minus 5 is 6. Okay, so after he empties the first bottle, he still needs 0.66 liters to meet his requirement. So the least amount of water that he'll have to put back in his container is 0.66 liters. So he will need to fill his bottle with 0.66 liters when it is empty. Okay, so I did that. Express your answers in liters. They're both in liters, so I am all set.